Chapter 6 on MultiArea OSPF. In this chapter, we'll look at how MultiArea OSPF operate in your network. Why do we need to use MultiArea OSPF? What are the link state advertisements used in the MultiArea OSPF? And how do MultiArea OSPF router establish their neighbors? We also look at how do we implement MultiArea OSPF in both version 2 and version 3. Okay, we look at the different configuration and how do we verify that your MultiArea OSPF work in your network. Okay, first, let's look at why we need to use MultiArea OSPF. Okay, in a single area OSPF that we learned previously, it works well when your network is small. But as you add more and more routers in your network, so your network grows bigger and bigger, your routing table will naturally grow bigger and bigger. With a large routing table, your router will run slower. Because for every packet that enters into the router will need to look at a large routing table in order to decide how to route the packet. So with a large routing table, your router tends to run slower. You need to search through more entries in the routing table to decide how to route the packet. And also, when you add more and more routers to your network, your link state database will also get larger and larger, meaning your router will need more memory requirements and also more processing power in order to process the large link state database and also to store the large link state database. And finally, with more and more routers, okay, the probability of a router failure will increase. So you have more chance of router failures. So with more chance of router failures, your routers will need to run your shortest path algorithm more frequently. Every time a network is down, they need to run a shortest path algorithm to decide if there's another alternate path to go to that particular network. Okay, so with more and more routers, the chances of a path go down or a router go down will get higher. Then the router will need to run more frequent shortest path algorithm calculation. So your router will spend more time running this shortest path algorithm calculation, okay, instead of routing your packet. So this also slows down your network. Okay, so in order to make your OSPF run more efficiently and is more scalable so that it can be used on larger network, OSPF support hierarchical routing using multi-areas. Okay, with multi-area OSPF, we divide a large routing network into smaller areas. So a large OSPF area is divided into smaller areas. So with smaller areas, it helps to reduce your processing and memory requirements of each router. Each router will only need to take care of their own areas. Okay, things that's affecting in other areas, okay, will not affect the own area. Okay, so with a reduced area, it helps to reduce the processing requirement and the memory overhead of each router. But this requires you to design a hierarchical network. Okay, but the design is not too difficult because there's only two main layers. One is your backbone areas and the other one is the non-backbone. So you only have the backbone areas and the non-backbone. Backbone areas are normally given the number 0. So area 0 belongs to a backbone and the other numbers belongs to the non-backbone areas. The advantage of running multi-area OSPF will help to solve the problem with a single area OSPF. You have a smaller routing table because you can do route summarization in each routers, and your link state update, okay, it will be reduced, okay, because the link state update will only be contained inside one areas. So your link state database will also be smaller. And failure in one routers normally will only affect the shortest path calculation of that area, okay, of those routers in that area. It will normally not affect the other routers in the other areas. So this helps to reduce the frequency of your shortest path calculation. Okay, multi-area OSPF, as mentioned previously, is a two-layer area hierarchy. Okay, there's only area 0, which is a backbone area. Sometimes we call it the transit area. Okay, the purpose of this area is to interconnect with other OSPF areas. Okay, so this area, sometimes we call it the backbone, okay, because it interconnects the other areas. So this is also called the area 0. Okay, the other areas is called the non-backbone area. Sometimes we call it the regular area. Okay, so these routers normally connects your end users, okay, or connect your geographically grouping, your finance department, HR department, okay, and so on. Okay, and if you want to communicate between areas, you must use area 0 in between the areas. So any users in area 1 who want to send packets to users in area 51, okay, the packet must go through area 0. You can't connect it this way. Okay, you can't connect it this way, meaning you're going to bypass the area 0. So the packet you're going to send, you're going to bypass it. This is not allowed. Everything must pass through area 0. So this is your 2-layer area hierarchy. Okay, now we'll look at the different type of OSPF router in a multi-area OSPF. Okay, the first one we have is the internal routers. An internal router is a router that have all the interface connected in the same area. Okay, in the same area. So in this case, this router, this router, this router, this router are internal routers because all their interfaces are connected to area 1. Okay, same thing for this group of routers. They are internal routers because all their interface are connected to area 51. The same with these two routers. Okay, these two routers their interface are only connected to area 0. Okay, how about R1 and R2? R1 and R2 are not internal routers because R1 have one interface connected to area 1, the other interface connected to area 0. R2 have one interface connected to area 51 and the other interface connected to area 0. So R1 and R2 are not internal routers. So in this diagram, all of them are internal routers except R1 and R2. Okay, the next classification of OSPF router in a multi-area OSPF is called the backbone routers. Okay, backbone router is a router that is connected to the backbone area, okay, which is area 0. Okay, so in this case, these 4 routers that is highlighted in orange, okay, they are the backbone routers because they have at least one interface that is connected to area 0. Okay, next, area border router. An area border router is a router that have interface that is attached to multiple area. Okay, so in this case, R1 and R2 are area border router because they have interface that is connected to more than one area. R1 have interface connected to area 0 and area 1. R2 have interface connected to area 51 and area 0. So R1 and R2 are area border router. So you have noticed that internal routers and area border routers, they are exact opposite. Internal routers all interface in the same area. Area border routers have interface connected to more than one area. So a router can be either an internal router or area border router. Okay, so they are the exact opposite. So internal router are all the routers here except R1 and R2. Area border router is R1 and R2. Okay, the last type of router is called the Autonomous System Boundary Router, ASBR. Okay, this is a router that have at least one interface that's attached to external internet network, okay, which is not part of your OSPF routing domain. So in this case, R1 is connected to the internet. This internet is not part of your OSPF routing domain. Okay, you don't share your routes to your internal networks with the internet. So this is an external network. So R1 have a connection to the external network, R1 is a ASBR. Sometimes you may also have a connection to an external business partner. So if R2 have a connection to a business partner network, R2 is also a ASBR because similarly you don't share your OSPF route, okay, with a business partner. So normally you only run static route between you and the business partner. So in this case, this is not part of your OSPF routing domain and R2 is connected to it, so R2 is also a ASBR. Okay, in our next video, we'll look at the different link state advertisement that is used in a multi-area OSPF.